question 2. So question 2 in tutorial 13. So question 2 in tutorial 13, we have a flask with volume of 1.5 liter. Provide with a stopcock contain the eating gas at 300 Kelvin and atmospheric pressure 1.013 to the power of 5 Pascal. The molar mass of eating gas is 30.1 gram per mole. The system is warmed to a temperature of 490 Kelvin. So it's warmed to a temperature of 490 Kelvin with the stopcock open to the atmosphere. So the stopcock, without any stopcock, so the gas is open to the atmosphere. So we understood that the pressure will be the same with the atmospheric pressure, 1.013 to the power of 5 Pascal. So we warm this one into a temperature of 490 Kelvin. Okay, so then what happened? The stopcock is then closed. Then I take the stopcock, I close it, so I redraw the diagram. So I close the flask, and the flask is cooled to its original temperature. So the stopcock is closed and the flask is cooled to its original temperature. So what is the original temperature? The original temperature is 300 Kelvin. So I have two situations here, so I denote the initial situation. So I denote the initial situation with V1, T1, P1. This is the final situation after I put the stopcock to close the flask. So this one will be my P2. So I want to find what is the final pressure of the ethene in the flask. So class, we want to find P2, the final pressure. What is the final pressure? So basically, if we recall, we have three gas law: Boyle's law, Charles' law, and pressure law. So which law we are going to apply to solve these questions? So we have to identify what variable is constant for this process. So if we notice that we are using the same flask, it means that our volume is constant. Our volume is constant. So our volume is constant at 1.5 liter. Okay, 1.5 liter. So for constant volume, our pressure will change with temperature. So we might solve the question by using pressure law. So we can apply the pressure law. So we have P1 over T1 equal to P2 over T2. Then we put in the value. My P1 will be 1.013 to the power of 5. The temperature initially is 490. So I want to find my final pressure, whereby the temperature is 300 Kelvin. So solve it, you will get the P2 lah. So you might pause the video to calculate the value of final pressure. So if you calculate correctly, you will get the value will be 6.202 to the power of 4 Pascal. Okay, so we have solved question A. Now we move on to question B. Question B will need us to find how many grams of ethane remain in the flask. So after we close the flask, it cooled down to its initial temperature. How many grams of ethene gas remain in the flask? So class, how many grams actually is referred to? So how many grams actually is referred to mass? Okay, mass. So class, the mass of the ethene gas we can relate with numbers of mole, N, whereby we know that the numbers of mole is mass over molar mass. Okay, and we are given the molar mass of the gas. The molar mass of the gas for ethene is given 30.1 gram per mole. So we might use ideal gas equation PV equal to nRT. Then we refer to the final conditions. We can refer to the final conditions. So the pressure we already calculate. The pressure is 6.202 to the power of 4. And then we have the volume. Volume is 1.5 liter. But then bear in mind, class, liter have to change to meter cube. Our SI unit is meter cube, whereby 1 liter is 1 to the power of negative 3 meter cube. So I change it to meter cube. So it will be times 10 power of negative 3. Okay. Then the molar mass I relate with the mass I want to determine. So I have mass over molar mass. The molar mass will be 30.1. So class, be aware the molar mass is in gram per mole. But when we do calculation, our mass is in kg. Our mass in kg. So we need to do unit conversions. Times 10 negative 3, we change gram to kg, we change gram to kg. Then we have the molar gas constant. The molar gas constant is 8.31. Then the temperature, the final temperature is 300 Kelvin. So class, we can calculate the mass of the eating gas lah. So you might pause the video to do the calculations. So if we do the calculation correctly, we will get the mass of the eating gas that remain in the flask will be 1.12 to the power of negative 3 kg. Or this one is equivalent to 1.12 gram. Okay.